So this is the first practical, that is to determine the phase diagram for the three component system, that is water, chloroform and acetic acid, or water, toluene and acetic acid. So out of these two systems, one of the system is given to you in the exam, so you need to determine the phase diagram for that particular system. Okay, so phase diagram part is the that part where we can actually establish the solubility curve or the dissolution curve for the particular given system. Okay, so here we have been given with the system, say water, chloroform and acetic acid. Out of this water and acetic acid, as well as this chloroform and acetic acid, these are completely miscible with each other. But this water and chloroform system, they are completely immiscible with each other. Okay, so we know that this water is being the inorganic system and this chloroform is what, organic system. So these are the immiscible liquid pairs, but this acetic acid, water, or chloroform and acetic acid, they form the completely miscible liquid pairs. Okay, so these type of systems are given and we need to construct the phase diagram for this given system. Okay, so what is the use of this phase diagram? So if you want to like have the purification of this three component system, so if we have been like already have the mixture of certain solvent, like say water, chloroform, or water, chloroform and acetic acid, likewise if we are having the mixture of solvents, so we can be able to like separate or the purify the liquids by using these phase diagrams. Okay, so basic use of this phase diagram is to get the exact concentration, and by using that composition or the concentration of that particular system, we can be able to easily separate out the each pure component, so that we can have the pure component in the individual form. Okay, so this is the use of this phase diagram. So what is the aim of this experiment? So aim of this experiment is to determine the phase diagram for the system of water, chloroform and acetic acid. Okay, so what are the requirement for this experiment? So we will be requiring 9 glass toppered bottle, that given solution of chloroform or toluene. So here we are mainly seeing this chloroform system, then distilled water and acetic acid. So these two liquids will be the common one, only the chloroform or toluene will be the differ one. So we will try to prefer the chloroform. Okay, now what is the procedure? So we have been given the 9 glass toppered bottle, so we have to prepare the different 9 mixture of chloroform and acetic acid, and we need to titrate it against distilled water. Okay, distilled water or the tap water. So prepare 9 different mixture of chloroform and the acetic acid in the glass toppered bottle, taking the following 9 volumes. Okay, so we have been taken the 9 volumes, like chloroform is 3 ml, 5 ml, 6 ml, 7 ml, up to so on 12 ml in the glass toppered bottle, and within the same bottle we have been added this acetic acid. Okay, in the decreasing amount, that is 12, 10, 9, 8, 7, as such up to 3 ml. Okay, so here we are seeing that the total volume of the given system is comes out to be what, it is around 15 ml. Okay, so the total volume of the given system is 15 ml. So overall we have to find out the equilibrium volume. Okay, so how will we can find out this? So this is the practical where we can titrate this mixture, say first bottle against the water. So in burette we are having the water. Okay, so this is the practical where we will titrate the given mixture with the water. So water is our titrant. So once we have prepared these 9 mixtures, okay, keep this bottle in the water bath so as to attain the room temperature. Then titrate each mixture with the distilled water, adding the small amount at a time. So once we have got to the turbidity in the solution, we can say that the end point has been occurred in the given mixture. Okay, so initially when we have mixed this chloroform and acetic acid together, this chloroform and acetic acid, So we are having the clear solution, like they will form the homogeneous pair of liquids, so we'll get the clear solution. So there is no as such turbidity in the given solution. But once we have started this reaction of this water, or once we have started to add the water from the burette, we'll get the turbidity at particular point. So when we get the turbidity, permanent turbidity, that will be the end point of our that particular mixture. Okay, so what is the observation table? So the observation table consisting of that various volumes that we have taken, that is the total volume is 15 ml. So in first mixture we have taken 3 ml of chloroform and 12 ml of acetic acid. So we need to find out the weight because we need to find out the total composition in terms of percentage composition in terms of weight of the particular component. Okay, so how will you find that weight of this chloroform acetic acid? So we just simply need to use this formula, that is density is what? Mass per unit volume. Okay, density is mass per unit volume. So simply use this formula, you will get the mass or the weight of the given component. Okay, so density is given to you, that is density for chloroform is 1.478 gram per centimeter cube. For acetic acid it is 1.050, or sometimes it might be vary from the bottle to bottle. Okay, so when we will perform this experiment in the lab, we definitely use the density which is given in the bottle. Okay, so it might vary little bit. So for this reference, we'll directly use this type of density values. So based upon that density values, we can actually get the uh, amount of this chloroform and water. Okay, amount of chloroform and water. So once we have got to the weight of this chloroform or acetic acid, we will have the that weight of that two components. Okay, now we have been left with only water, weight of the water, and we know that this certain endpoint will be there. Okay, so once we have got to the that particular endpoint, that tighter volume of the water will be nothing but what? The weight of the water. Why is it so? Because the density for water we have arbitrarily taken as a 1. Okay, so whatever the amount of water that will become as the endpoint, that much the same amount of water in the gram also required for the neutralization or the for the endpoint. Okay, so this will be the, say, overall, suppose this is a, b, and this will be the c. Okay, so if we add these three together, that we will write in this total weight of mixture, that is the total amount of mixture. Okay, total weight of the mixture. So if you want to like find out the percentage composition of final mixture by weight, if you want to find out first, say suppose for chloroform, what we will do, simply we will make this calculation, that is a, that is weight of chloroform divided by total weight of mixture, that is a plus b plus c. This is the total weight into 100. Okay, so this will gives you what? This will gives you the percentage composition of the mixture, that is chloroform first. Similarly, if you want to find out for acetic acid, so instead of a, we will take here weight of the acetic acid, that is b, divided by a plus b plus c into 100. This will gives you the percentage of acetic acid. And similarly, if we take on c here, here c we have, if we have taken c, then we can get the percentage composition of water. Okay, so likewise we will get the 9 different values for the different composition. So once we have got to the different values for the composition of various component, that is acetic acid, chloroform and water, we can have the this triangular plots. Okay, triangular plots. So this type of plots are used for the three component system. Okay, so we have like already seen this type of plots in the theory parts. Okay, so there for the three component system, we are having this type of triangular shape graph. Okay, so graph will be the percentage of weight of each component on a triangular graph paper. So we need to draw this graph. Okay, so on the each corner we are having the 100% pure of that particular component. Okay, suppose we are having, say, water is here, then acetic acid is here suppose, and this here we are having the chloroform in this corner. Okay, so at particular corner we are having 100% of that particular component, and if we move away from this corner we get decreasing amount of that particular component. So suppose here acetic acid is 100%. If we move to that point, say up to this point, so here the amount of that acetic acid is around what, 25%. Okay, so their amount of acetic acid is decreasing like from this corner to that side. Okay, so likewise water also amount, here it is 100% water, and if we move from this to this side we'll get decreasing amount of water, say around at this point we are having only 20% of water, and at this point or the opposite side the amount of water is 0. Okay, so likewise we will get the uh, percentage of the particular component. So we need to plot the various percentage, that is for chloroform, acetic acid and water. So suppose we are having the three different readings like for chloroform, acetic acid and water. So we need to just plot this. For acetic acid we need to consider this point or this as the origin, for water we need to consider this as the origin, and for chloroform we need to consider this point as the origin. Okay, this point as the origin here. So likewise we need to plot the graph. So finally you will get such graph. Okay, if you plot the means experimentally, if you perform that experiment, you will get the graph having this type of nature. This type of graph is called as what, binodal curve. So this is called as a binodal curve. So we'll get the binodal type of curve for this three component system containing chloroform, acetic acid and water. So this is the output of our experiment. Okay, so above this binodal curve we can say that there is a homogeneous system, and on this graph or on this plot we are having the heterogeneous system containing the, okay, three components, that is water, acetic acid and chloroform. So likewise we can make the certain conclusion. So this is the experiment, that is to determine the phase diagram for the given system of water, chloroform and acetic acid. Okay, so this is the first experiment. So here we are having this um, two types of calculation. One is to find out the weight of each component, and another one is find out the composition of each mixture. Okay, percentage composition of each mixture. Okay, so now in next we will see this second potentiometric practical or the instrumental practical.